All right. How is everyone doing? Yeah? So, I know that you all have been drinking from a fire hose and been thrown a lot of content at you. We're gonna take it slow. It's gonna be live action. It's gonna be really fun. My name is Kristin Kostka. I'm the director of the OHDSI Center at Northeastern University. I am an epidemiologist by training and a one-time Titan Award winner. So I have a little Lego person over there if you want to make a stop action movie with me later. But I'm going to talk to you about my favorite topic, characterization. And Gautam made this really easy for me because it turns out cohort diagnostics is a form of characterization. So I promise this will be fun. I promise we're gonna look at the tool, but I'm gonna just give you a couple of framing slides because at this point in the day, I'm not even sure if you guys remember that we're going on a journey together, that we're like driving into a destination where we're gonna generate evidence. Do you guys remember this slide? Have you seen it like 600 times already in the last 2 days? Excellent. So this is seared in your memory. It's really important to remember that we have different Lego blocks. So I know that like you guys are like, oh, well, we had the whole interactive exercise yesterday, but think about these because they're going to become really important when you are characterizing. And this is just a subset of the domains that we have available to us, and we can talk about other Lego blocks not in this list. So why bother with characterization? Anybody have any ideas on why we bother characterizing? It's just like summary statistics after all. It's so boring. Why would you do it?
It's how you get to know your data.
You get to know your data. Okay, yeah. Any other thoughts on why we bother with characterization? Nobody? It's so boring. You're just not going to do it? Validation. Yeah. Yep. You can definitely do that. And maybe I should have started with the question, do you guys even know what characterization is? Yeah? Well, good news. We're going to go through it now. But I want you by the end of this to feel like it is totally worth bothering with characterization. It is your gateway to every other study design that you're going to do. And there are lots of things available to you, both in Atlas as well as if you would prefer to code it. So you've already got a loose primer on some of this. It's going to be quite fun. If you think about it, there's a lot of elements that we can characterize, right? We have the conditions that we see. We just talked about the nuance of when they onset and in validating that. We can talk about drug exposures, other procedures that you have, measurements, or for those of you who are less familiar, those are your labs. And of course, we can characterize an anchor time around some index event. We've been talking about that in our cohort building steps. There's baseline time, there's follow-up time. You might string together and characterize treatments, diseases, and outcomes. And all of these things kind of follow the same math. We're just stitching together a view of some point in time for that patient and all of these attributes around it. And we can stack them, right? So like I can have, I guess at one point I had an animation for this, but like I can have many journeys that look kind of the same, but also kind of different. And they can be very subjective. So sometimes we need to think big picture. Sometimes we'll think at the individual level. Depends on the type of question you're asking. But they're all incomplete, right? That's kind of the fun of real world data. And it's worth saying that when I say it's the beginning, you know, it's this trifecta of really cool things we can do. We can start by asking what happened to them. That's just observations. And then we can move into what we'll talk about later, which is our population level effect estimation and our patient level prediction. But they all live in harmony. We have to share good cohorts, and we have to understand what's available to us in the data. And you can ask a lot of different questions when you do that, right? So which treatment did patients choose after the diagnosis? What patients chose which treatments? How many patients experienced the outcome after the treatment? What's the probability that it will develop disease? Probability of experiencing an outcome? Does a treatment cause an outcome? And is there an alternative? So lots of layering. The orange boxes are where we're going to start. And then I have some friends who are going to join you in your journey as you choose other study designs. And I think what you should walk away from this one is that there's a real unsung hero in our toolkit that's going to make this all possible. So how many of you have used Hades or have any familiarity with what we used to call our methods library? You might know that artist, like if you're a real OG. Have you used Hades? If you call it methods library, you'll get street credit too. If you've used Hades or maybe heard about it and want to pretend you've used Hades, we're going to do it right now. I want to spotlight the unsung hero of Hades, feature extraction. And why is it the unsung hero? Well, thank you for asking. Because it really is the best supporting package in my not so humble opinion. It's generating all of our covariates and doing so with all those cool things that Gautam showed you, all those different cuts that he was able to quickly generate plots. This is your supporting actor here who made that all possible. So if you want to read about the package, you can actually go into, this is the vignette that Martijn has for the documentation. There's obviously the GitHub repo, but we're going to see it in action and really get to kind of experience the fun of just add water characteristics. So when we talk about characterization, I want to reorient you to some terms that you might hear a lot in the OHDSI ecosystem. And they're really, really simple. We have target cohorts, those are who we're going to characterize. We then talk about things like subgroup cohorts, and that's really, subsets of that target. So do you guys remember any subgroups that we looked at? Anyone remember what we might have stratified on? Age, yeah. Gender, maybe? Yeah, I mean, there are lots of ways to get fancy with it, but it's pretty easy to do in the tooling. And the feature cohorts are really the outcomes that we're characterizing. And a big thing that we want to talk about is time at risk windows. So Gautam was awesome and was like, you can do it this way, you can do it that way. But every one of those combinations may be a consideration of time at risk. And you will define those for all of the features and concepts that you're looking at when you're characterizing a disease. So how are we feeling? We feel like we got this? Because I'm going to quiz you on it. No, I'm not. So one last thing, which is, I think it's worth reiterating that OHDSI has a very specific definition of a cohort, and we might have blazed through this earlier, but this is really important, that underline line, for a duration of time, a set of persons who satisfy one or more criteria for a duration of time. Why am I harping on this? Because you might, in your prior training, have a different definition of cohort, and you might not have that last contingency there. That tends to be a very OHDSI way of describing cohorts. And of course, cohorts are a phenotype for a duration of time. One person can belong to multiple cohorts. You can be in the same cohort at multiple points of time, depending on those entry and exit events. But it's really worth saying, a code set is not a cohort. Repeat after me, a code set is not a cohort. Excellent. All right, you've been initiated. You're ready for your mission. So we're gonna talk about this in live action form, but you can really think of it very simply. Who do we want to study? What subgroups do we want to study? What are attributes we want to look at and describe the differences in? And what are windows of time that we want to describe those features? So easy, right? Like even a kid could do it. I think Catherine is probably pretty good at this. That's Patrick's daughter you saw yesterday, but she's really good at this. So when you looked at cohort diagnostics, what you might not have appreciated is under the hood, there's all these descriptive statistics. So we take a step back out of the exercise of scrutinizing your cohort. These are sort of your building blocks that you were inadvertently already using. We were looking at the magnitude of difference, that's the cohort counts. We spent a little bit of time in the visit context. Really, that's the patient care setting. We have the ability to look at cohort overlap. We didn't do that as much, but we can talk about how cohorts converge, how they are different. We'd spent some time in incidence rate, and those are, baseline. Gautam kept saying, does this seem right? Which is like my favorite question, because it's like, to whom? How? Am I an expert? Well, trust me, I'm an epidemiologist. I totally know what I'm doing, right? Time distributions, those are gonna be before, during, or after, and someone said, what's the difference between simultaneously and during? Excellent question. Because it matters, right? How we define in that box. And there's lots of ways for our logic to describe that. And of course, the index breakdown, how somebody enters a cohort, is a big place we can characterize. In fact, we spend a lot of time debating that. We talk a lot about, is that the right point that they should be qualifying for this cohort? And of course, then we can characterize all the ways we can cut time. That's part of it. So cool, we're feeling good. All right, who wants to go to Atlas? Yeah, we want to go live action? We're gonna try this. Let's all break Atlas. That's my favorite thing to do. Where is my browser? There's so many icons on this toolbar. This is Patrick's computer. So you're in Atlas. If you were going to start a characterization, how many of you have used Atlas below the cohort definition tab right here? Have you ever gone into like what I call the advanced part of Atlas? Like, is this your first trip? Has anyone used characterization? Ever used it? You ever used cohort pathways? Yeah. Don't worry, we'll come back to that one. You might actually be using it without even realizing it sometimes. And has anyone used incidence rates? A few, all right. So what's really we're saying is in our mature Atlas now, we actually have many ways to tackle characterization, which is really cool. I remember the days when there were less tabs in the left panel of Atlas. So you guys are all really fortunate that today you have options for your characterization, and that feature extraction package is really doing the heavy hitting. So I will just very briefly kind of walk you through the different tabs, but let's start with the one that I think will probably be most familiar. So incidence rate, we were just kind of scrutinizing this in that cohort diagnostics visual, but let's say you want to design your own outside of that Shiny app. So we'll come back to this example in more detail, but I just want to orient you to what you're doing in this tab. This is where you're going to take those target cohorts, and after you've spent some time with Asya and she taught you how to build some cohorts, she taught you really fast. So good news, I got some JSONs for you. They're preloaded. You're ready to go. You want to figure out who qualifies, right? That's your left. You can retrieve these. You can add target cohorts to your heart's content. And then you want to count on the other side some outcome of interest, right? And I'm already going to give away the answer because it's there, but do you guys remember what we were maybe interested in seeing develop? Does anyone remember besides AMI? That pesky angioedema thing, it's actually pretty terrible. We want to know what's happening, right? So really simple, right? We have our target cohorts, we have outcome cohorts, and then we have time at risk windows. And we can get really fancy. Today we're going to keep it kind of simple because I heard Gautam say 1 day, start with 1 day plus 1 days. And down below is sort of the beginning to put those subgroups into a framework, right? So we have a gender criterion. It looks just like that cohort screen. How awesome is it that the interface is the same regardless of what tab you're in? And you saw Asya quickly add a criteria to the group. Here we're going to look at females since we know there's a gender difference. And we have an age criterion. We also have a race criterion. If you pay attention, this is your extra credit later. You might be able to recreate this. So what is it doing in this tab? Basically, we're starting that math of among people who are in one of these target cohorts, we're counting when they develop these outcomes of interest. And in the world of Odyssey talk, you'll hear a lot about T's, C's, O's. Does anyone have a guess what the C stands for? You see target, outcome. What's the C? Comparator. Yeah. So in this view, you actually just have two targets, but you could be comparing, the same disease. You could be looking at two different diseases. Or in this case, we're looking at two different new user cohorts of different drugs, right? And it looks so simple, right? This is really like denominator, numerator math, right? Epi is so easy, right? It's just algebra. What's really cool about what's going on under the hood is that when you generate it, it can do this really neat math where it then takes your left and your right, and it'll create the different combinations of the cohort. So if I select over here, once I've hit generate, I can pick either I'm in the hydrochlorothiazide or the lisinopril cohort. And I can also see the outcome cohorts. Oh no. Fatal mistake. I hit generate. This is why live demos are fun. So we'll let it run for a second. We'll see how quickly it comes back. But while it's doing that, it does have, you guys saw there was actually a little tab. So every time it runs, it's going to give you a view that you can actually click in it and then see these little tree maps. And the tree maps will be vibrantly colored based off of those criterion you've put into Atlas. So in that definition tab, we built some stratification criteria. Those will come up as something you can toggle. I'm terribly regretting that it hit generate. But, oh, look at that. It came back. Oh, it got canceled. Uh-oh. This is why you can't be impatient. So we'll let that one run while it's doing that. But, so incidence rate, really simple. And very soon you're going to get to play with this. So pay a little attention. But I want to give you a little tour through some of the usual suspects while that's computing. So we're going to go back to slides only for a minute, I promise. Because cohort pathways was sort of our first foray into characterization. Has anyone maybe read a cohort pathways paper by I don't know, a guy named George Ripsack? Ever seen that one? Have you guys seen this paper? Does anyone know it? It's real OG Odyssey. It's 2016. It was actually it was made before Atlas has this functionality, but what's really cool about this paper is that it's a good example of how you can use that cohort pathways. And so this is a paper I can share with you all. It's kind of what I'd call a big monumental paper from the community. And I heard a rumor that it was basically made in AMIA. They were sitting in a bar and they had a napkin and they just wrote out the combinations and then they went into SQL. You now get to go into Atlas and do it quickly. And what's really neat about the cohort pathways are these sunburst plots. Do you guys use sunbursts? Are you familiar with them? Yep. Does anybody want to tell me what we're looking at? And I want to take a guess. Anyone feel confident?
First and second and subsequent lines of therapy and combinations of those.
That's right. So this plot has we have the question at the top, which is excellent because, how would you know, right? If I didn't label the plot, you'll just have sunbursts. But how are patients with major depressive disorder actually treated? And this is a plot looking at different lines, and there's different drugs here. And we talked a little bit earlier about the concepts that we standardized to. So does anybody have a guess what ontology we use for the drug exposure domain? Do you remember what Claire told you? RX norm, yes. So there are RX norm concepts behind these. And we're basically just plotting the frequency. And as it goes out, that's the line, and they get smaller and smaller. And so this was our first big one in Odyssey. This study was just summarizing and looking at just counts of how things happen. So sounds so boring, but actually there's a lot to be said about the heterogeneity of where and how we treat. And there's a lot of variations. So that was one database. You can then run it on many, and that's really the beauty of Odyssey network research, right? And these are plots across a number of different databases. Some of them might even be your own institution. If you're from a JU, you're in the top left. There's a couple of American data sets in here, big claims, got Columbia. There's one from Japan. But it's kind of amazing when we see a statistic like 11% of depressed patients followed a treatment pathway that was shared by no one else in the data. How wild is that? And that's why you should bother with characterization, because if we don't ask the question, how often, and who even, we don't know that. We just think that we're just magically going to have clumps of patients that all look alike and have all these great information. And then you can ask more questions. Again, we can ask about choosing treatments and which patients did what and how they experience things. And then we have all these things that we'll do in fancy sections coming soon. So, all right, we're going to go back to Atlas now, and hopefully it's computed. Talking about the incidence of myocardial infarction in that lisinopril cohort. So I didn't show you how to build a cohort pathways because I just didn't feel like making the event cohorts. But if you're in Atlas and you just want to know real quick, I'll show you an example. It's the same idea if you want to replicate George's paper with this functionality, you'll put the target cohort, and then you have to create event cohorts for those drug exposures if you're doing drug events. You could also have procedure Jenny has some really great work that she did in MSK AI that is procedure-based cohorts. She could send you a JSON if you want to try to run hers, but that's the fun part, right? You can actually put lots of things. Events is a big bucket. You just have to create the qualifying, and then you can have the different analysis settings that collapse those cell counts. Pretty neat. And then when you execute it, I'll just show you. It looks like George's paper, but George and crew didn't have this functionality available to them when they did it. So you are very lucky. Look at that. You got a whole paper you could write. So I'll see you at the bar at 5, and I want to see the draft. Yeah? You guys are like, she's the worst, man. Bring back Gautam. All right. So let me give you the context one more time since I talk a lot. All right. Incidence of myocardial infarction among new users of lisinopril they're on treatment. So is anyone feeling daring? Does anyone want to be my Vanna White and help me do this? I gave you all the building blocks. It's actually already done. You just have to help me explain it to your friends. Think you can do it? No confidence. All right. Let's see how it is. If you were in my Zoom class, I would just spotlight one of you and be like, it's your turn. You got this. So which cohort on the left are we talking about? Does anyone remember? Lisinopril, do we remember how that started? Does anyone remember the logic for that? So I'm asking some good questions. Nobody remembers this cohort. All right, we're gonna go backwards. Here, I'll show you. Actually, I think you could just click. So I'm actually gonna copy the name. Why am I giving you a hard time to remember the cohort? Because if you don't remember what you did to create the cohort, you're not gonna remember what the statistics are when it generates it, right? So lisinopril. There we go. Is this one? Yes. Okay. Remember, this was really simple. We had a drug exposure, first time ever, 365. They have hypertension in the prior 365. They have a continuous exposure exit criteria. We feel good, right? Yeah? Okay. Now, the AMI cohort, does anybody remember off the top of their head how we set that one up? Or did you? I don't actually know if we went through the logic, but it's been hiding in plain sight. It's in here twice, but I'll put this one in. So that is a condition occurrence of this AMI concept set. And then we had that ER criteria, inpatient and ER visit criteria. And then we also had that restriction for no AMI in the prior 365. Does anyone know the difference or have an idea of like the outcome cohort? It looks kind of different than the target cohort. Anybody have any guesses on why they look like that? Like, this is a very different looking cohort, right? Anybody have any feelings on it? No? All right, I'll lead the witness. So, outcome cohorts in characterization studies, they're basically kind of a giant box of outcomes that you'll then append to all of that inclusion logic you made for the target cohort. So, they are just a freestanding thing you were looking for. Why do I bring that up? Because outcomes by themselves are interesting, but they're more interesting when you've nested them in all that logic you put in the target cohort. And so you don't have to recreate that. They come together, and that's what the template does. And if that doesn't make sense, I'll show you what I mean. So
you're basically getting to overlap between the two, yes?
Yeah, kind of. Yeah, exactly. If you were in cohort diagnostics, you might kind of see, well, you can stack some of the logic. So here, I'm going to pull up the lisinopril with prior hypertension in the AMI. So we have this AMI with a hospital restriction. We have new users. And what the report will do is basically, like the intersection of those things. Very simple algebra. And it's actually quite cool. So does somebody want to take a gander at reading what this says? I've given you all the prompts. You can do this. I believe in you. Oh, damn it, I hit run again. Oh. Listen, this is why you can't use someone else's computer, because you just hit keys. So, good news, it's not going away. But what are we looking at? Does anybody know what we're looking at? So among people who are new users of lisinopril, with that criteria of being 365 days in the data, first time in their history, they have 378 cases of acute myocardial infarction. Yeah, you said it's so great, but do you want to say it louder? No, he's like, no, Kristin, you can hear me and tell everyone else. Okay, so we talked about this is all relative, right, to those two cohorts that you've defined now in this Pharmetrics database. Does anyone remember what population Pharmetrics covers?
Claims in hospital, pharmacy.
Yep.
Adjudicated claims data.
And anybody remember what country it's from? It's real low-hanging fruit. US, yeah. So we're looking at a commercial claims database in the US. We see 378 cases of this combination of among new users of lisinopril that go on to that outcome of acute myocardial infarction. And then what it's showing in the shading is actually we added some stratum on gender, age, and race. You don't have to fill that in when you do Atlas. You can leave the stratum section empty and it'll just be one square, basically. Your plot won't be as pretty, and we're lucky, right? So this can also tell us the angioedema cases. This isn't the example, but it's just to show you that you can I have to stop hitting this button. I honestly think it's just, he probably has an app that's just gonna keep hitting it for me, but we can do this really quickly. And I think we take for granted how awesome just that is. I know characterization gets a bad rap. Like, that is not like trivial. You just took, you can switch your drug exposures, right? You can have your other, I'm gonna try really hard not to hit. You can have a comparator cohort, so hydrochlorothiazide. You could then say, well, what's the difference? You can compare. And it's a different case rate of angioedema. Let's look at the AMI, because I know that number off the top of my head. So 289 versus 378. So this is your gateway to doing more sophisticated things, but you can start just by simply looking at the rates of these cohorts and these pairs of information. And that's what I wanted you guys to learn from today. So are you guys ready to try your own hand? I've already given it to you, so you just really can interrogate it. But if you want to play along and open your Atlas up, really the utility of these characterization reports is that it can then very quickly compare these cohorts. And does anyone have an interest in like causal inference studies? Yeah, some of you. It's okay, you're not gonna hurt my feelings if you say you like causal inference better than characterization. Have you ever had highly correlated covariates? Have you ever had that problem? Yeah, me too, and it sucks. Because when you're trying to fit a model, you can end up in an R console and it like never ends. It's just this progress bar. You're like, what is going on? How come like my propensity model is not getting fit? Propensity scores or whatever. This is your secret weapon into interrogating maybe what happened. So it sounds silly, but in order to get to that other place, you have to kind of know a bit about the distribution of the people you're studying. And I have been personally victimized by the highly correlated covariates. Instrumental variables are the worst. My secret weapon is between incidence rate. There's also this characterization template. So if you were to build a model and you wanted to balance these two cohorts, I highly, highly, highly suggest maybe taking a spin through this report functionality here. It's really easy. You can put in your two cohorts you're looking at. You can pick, because this is a really fun part, feature extraction. You just pick from the menu of the things that feature extraction can do. Feature extraction basically by definition can summarize on the domains we have, all those Lego blocks you saw, and it has time windows, right? So you'll see short, medium, long, like all time. And there's 105 preset just in the UI. So pretty awesome. You can do distincts. You can do even this hospital frailty risk score. There's a bunch of different indices. I did Charleston. That's my favorite, but there's tons. You can just pick from the menu, plop them in. You go down more subgroups if you wanted to stratify. I didn't And I know how not to hit generate on this tab. I use it a lot. So this will actually just give you quick comparisons. And so you might trim out, you have a lot of things you're looking at. Maybe I don't want to look at the drug exposures because it's a drug cohort. So maybe I just want to know distinct conditions, maybe look at their demographics. Give it a second. And this is a very quick, essentially like your 2x2, but blown out for anything you selected a domain for. So this is all prevalent covariates, but this one's actually kind of neat. It's talking about the distinct condition count long-term. Gautam was talking a little bit about like records and using information he knew from the literature. And so you might want to know if you have frequent flyers of the same variety in both cohorts, or if there's something disproportionate. You might want to know about their procedures, if you have procedure data. And so the one thing that we don't kind of cover in the template, but is implicit, is that you have already done your homework and you know what data you're using. So that's why I asked you, do you remember what data we're using? Is this so in commercial claims in the US, do we see old people? Like really old people? Sometimes. Do they keep working? That's the question. If they still have a job and they're getting insurance through their employer, maybe. But likely, after 65, that population isn't really there. So it's really important, right? Then if we start thinking about those age plots we saw, how much data is in that cohort? What am I interpreting with? So all right, live action time. You guys, I have an assignment for you. Are you ready? You want to play with Alice? No? Nobody wants to play with Alice. Everyone's like, no, I just want to go have coffee in the back. Let's try to do incidence among angioedema, or incidence of angioedema among new users of lisinopril. You have the tools, and as you saw, you can actually generate reports pretty quickly. I'm gonna let you guys try your hand. And I do have an extra credit assignment, which is if you wanted to try to use the subpopulations, which is why I had those preloaded so you can kind of see how those work. But we'll start with the easy one, which is just creating an instance report for angioedema among new users of lisinopril. So you don't have to create the cohort for the target cohort. You don't have to create the outcome cohort. It's like an easy bake oven. You literally just had the light bulb in there and you got this. All right, my friends in the back, do you feel good? I don't know if your screen's working or not. I can't see from here. But does anyone want to we can do a live together, but I want to see you guys cruise through Atlas. Since the best part is we have a real demo environment with real data.
I just have a question.
Yeah.
So how are you interpreting time at risk? I assume it's person years because it's a huge number. So if you were going to try to get this to a risk for a person, right? So that the rest of that nice diagram, how do you interpret that?
It's a great question. Oh, it is running. Okay. So it is going to be relative to, time in OMOP in general will be created around the observation periods. And are you familiar with observation periods?
Yeah.
And are other people familiar with observation period? It's a very OMOP-y principle, which is really this idea of we create entry and exit of when we think you're being followed in the data. So we use observation period as kind of an anchor, as sort of do you exist in here? Then, relative to your target cohort entry event, we will create time 0 from that entry event, obviously restricting for whatever we put in there. And then it'll be, basically we count time from that point forward. And then, so in this view, it'll be aggregate, but you could, on the scripting side, go and interrogate, these are definitely more meant to be summary statistics on the higher level. But Jenna can talk to you about moving things down to the patient level later. But yeah, so this is purely crude kind of counts of, Gautam was saying, does this make sense? Is this reasonable? And in Epi, you might say, but I want to adjust it for other things. That is not exactly what this template is for. It's the beginning of your gateway to get into more math.
Thank you.
Yeah. I'm gonna That's it. I just wanted to have them actually touch the interface. This one's easy. All right, my friends. In a minute, you'll get an energy break, but I want to wrap up this time with characterization with just a couple of highlights. So some of you asked some great questions. You said, I want to look at two things simultaneously. How do I do that in Atlas? Okay, so here's the secret. Cohort diagnostics as a package is this amazing contribution that builds on the hard work of what we have under the hood with feature extraction. If you would like to become a cohort diagnostics wizard, hang out with Gautam tomorrow. I know this is like a promo reel for his workshop, but like the package itself is really configurable. You saw in that Shiny app, you can kind of play and like decide how your logic does or doesn't impact. So I have a couple pieces of advice, having run many characterization studies in my life, and I was just telling some folks some of the regrets I have from our COVID work. If you don't define it, you can't count it. I know that sounds like really logical, but here's an example. If you ran a characterization and you have cohorts, your target cohort is a condition entry event, and then you have stratum for drug exposures. You're looking at how much drugs that they have in the first 30 days, next 60 days, whatever. If you want to flip it on its head and say, well, what happens if you start with the drugs they get and then the conditions? If you didn't build like a target cohort that starts with that and then the next thing, you can't just magically force it to give you that cell. Like it's a little box. It's just pulling numbers out. I don't know if that sticks or not, but I'll give you this happened. Somebody said, oh, in Charybdis, I want to look at cardiac liabilities and I want to start with just the drug list. I don't want to start with COVID as a definition. I want to start with drugs as the definition. The problem was all of our target cohorts were condition specific. So we didn't start with the drug exposure. So that is a lesson I learned after I solicited from 26, 25 databases, which Patrick says is a small amount, but I will tell you, even 2 databases is a lot to look at for characterization. And that's kind of the fun thing about it. Every database will look a little different. Even in the same country, there are just going to be different care settings. And the more that you understand sort of the dynamics of how that data, the environment that produced it, the easier it is for you to understand when Gautam asks you a question, do you trust this? Well, what is trust? No, we're not getting into that here. So I know Atlas is having a lot of fun getting everybody hitting it, but you honestly, there's tons and tons of public artifacts. So if you have an Atlas at home and you want to learn how to load these up, hit me up on the community call. I'm happy to show you guys how to import the JSONs. It's so easy now. It's amazing. Like, I wish I could tell you what the old world was like, but it would scare you. Ask Jenny when she was getting her PhD what it was like, and she'll tell you. So you have a break. Go get, dance around or whatever. We haven't had a dance party yet. It's a little late, but if you have questions, feel free to ask. And then, like I said, this is your gateway to more sophisticated study design. And you could write lots of papers just on that one screen that we just showed. I know it seems really silly. You're like, oh, well, Kristin, you generated in 5 minutes. Yeah, but writing a paper takes the rest of your life. So there you go. So go write your papers and get your coffee and come back at 2:30 to see Martijn, who is way smarter than me and gonna do much cooler stuff. So